to be talking about Newton's laws of motion and the forces that will be contributing to it. You will be needing to use your Newton's laws of motion worksheet, and this could be in your journal or just a handout. What we're going to talk about first is, what is force anyway? The four components of force. Why is it not working? They are a push, pull, they have size, and they use direction. Force always comes in pairs. It's impossible to have only one force. Alright, place a hair tie or rubber band in each hand and stretch it apart. Obviously, as you're pulling and stretching the rubber band, you can feel a force in both sides of your hand. The same thing goes for when it is placed on a peg. If you have it on a solid foundation and you're pulling it apart, it's pulling on your hand and it is also pulling on the peg. Next, we have net force. Net force is the sum of all the forces acting on an object. If the forces are in the same direction, then you're going to add them together. As you can see, if we have arrows, they are going in newtons. Force is considered newtons. If the forces are in the opposite direction, then you subtract the smaller force from the larger force. Remember, whenever you are going in the opposite direction, that you are going to write the direction of the greater force. Our next scientist is an English scientist who contributed to the 3 laws of mass. Sorry, not mass, motion. He was not doing very well in school, but through hard work and dedication, he continued his education to contribute to the science and math theories. Newton's first law of motion states an object in motion tends to stay in motion, and an object at rest tends to stay at rest until acted on by an unbalanced external force. Remember that an unbalanced force is something that is actually moving. Examples for this theory: a book sitting on a table will remain at rest unless it is pushed or pulled. A ball rolling across a gym floor will continue to roll until it is stopped by a person, wall, or when friction and air resistance cause it to slow down and eventually stop. Friction. It is a force that resists motion between two surfaces in contact. The 4 main types of friction that we will be talking about are sliding friction. This includes ice skating, rolling friction, such as going to the bowling alley, fluid friction, or air or liquid, air or water resistance, and static friction. The static is the friction between 2 objects at rest that keeps it from moving. The law of inertia is the first law. Inertia is the tendency of an object to resist changes in its velocity and acceleration. Inertia is sometimes related to mass, and objects with more mass have more inertia. So for example, in this next slide, you can see that the small car is going to have less inertia than the giant dump truck. Newton's second law of motion. It states that an object acted on by an unbalanced moving force will accelerate in the direction of the force. And when calculating force, we use F equals mass times acceleration. Alright, here are the units for force. Force is a capitalized F, which stands for Newton. Acceleration, we know, is the lowercase a, which is meters per second squared. And mass, the lowercase m, is going to be kilograms. Down at the bottom left corner, you have the triangle. It's similar to our triangle that we use to calculate speed. If you, for example, are looking for force, you would cover the F with your hand, and then you would have m across from a. That would mean to multiply mass times acceleration to find force. If you were looking for mass, you would then cover up the m. That leaves F on top of a, meaning force divided by acceleration. Alright, our first formula, F equals m times a. The force will be greatest when large objects have a high acceleration. Our next one, when we're looking for mass, m equals F over a. Mass is greatest when very strong forces can only cause an object to accelerate very little. Then looking for acceleration, a equals F over m. Acceleration is greatest when a large force is applied to an object with a smaller mass. Now, Newton's third law of motion, it states if object A exerts a force on object B, then object B exerts an equal and opposite force on object A. Keep in mind that the forces are on different objects and occur at the moment of contact. What is the difference between weight and mass? Mass, it is the measure of how much matter is in the body or object. The size of the object does not determine its mass. Weight is the downward force due to gravity. Weight is a force. If you'd like, remember, mass stays the same. Weight changes with location.